All right, welcome everybody. This is 6.2 quadratic applications. All right, please make sure you did 6.1 before you did this. Otherwise, this may not help as much, okay? So, today we're doing applications. This is like real life situations with parabolas. Whether or not you knew it, whenever you throw something, it follows the path of a parabola really close. And so we can model things like that using quadratics. Things like rockets and any sort of projectile is like a quadratic. All right, so let's get into this. A lot of these problems that you're going to have, or I guess all the problems that we have, we're not going to be asking for a thing like this, like specifically like y-intercept, x-intercept, and vertex. We're going to need to glean that information from context, okay? So what I'm going to ask you to do is to pause and look at this and see if you can match the definition with its critical part. All right? So give that a try, and then we'll go over it. All right, so I'm going to start at the bottom and go up, okay? So the bottom says, for definition, it says maximum height of the object. So if it helps, you can do a little sketch, okay? Oftentimes, for your graphs, your y-axis will be height, okay? Kind of makes sense. And then your x-axis oftentimes is either time or distance. And it could be other things too, but those are the most common, okay? So here if we're talking about, they're asking the maximum, what is the maximum height of the object? Okay, how does that apply, or how does that connect to our key features? Well, the maximum height here, maybe I'll do green here, is your y value of your vertex. Okay, so we'll just connect that dot, the y part, for your vertex. Next is initial height of the object. So initial height, that's like when time is equal to 0. All right, that's your y-intercept. Okay, so we'll connect that to our y-intercept. Okay, I'm just going to do the top one. It says when or where the object hits the ground. All right, so you can kind of think about that as when the ball hits the ground or something like that, something you threw. That's going to be your x-intercept. So that's what we're going to try and find there. And then our last but not least is when or where the object is at its maximum height. And that would be your x part of your vertex. So again, when or where, that's always going to be your x-axis. Okay, so something like this, this value is going to be your x value of your vertex. Okay. All right, well, I think it will help most if we just do a problem. So let's see where we're at. Okay. So a rocket is carrying fireworks is launched from a hill above the lake. The rocket will fall into the lake after it explodes. Okay, so like over here, maybe over here is our water, and the rocket is like taking off. Do my best to do a rocket, something like that, okay? And then once it hits its maximum height, it's going to explode, okay? I guess, I don't know, maybe it's not like the best example, because if something explodes, I don't know if it will fall as like normal. So anyways, but we'll just assume that it explodes at the top and then it continues in the same fashion until it hits the lake at the bottom, okay? All right, so the first question is, at what height does the rocket start? Okay, so I'd like, if you would, to at least write down what is that key feature that they're asking for. So what they're asking for here is your y-intercept. That's your initial value, okay? And at what height does the rocket start? Well, they just want to know the height, so that would be 80. 80, we have units here. I don't think it has units in here. Let's just call it feet. Okay, we'll use feet for this one. Okay, next it says, how high is the rocket after 1 second? Okay, so this is kind of like when we, on our last lesson, where we graphed the equation and then they asked, what's the y value when x equals 7? So that's kind of similar to that. So we'd say at 1 second, right here, would go up, and we would find its height, which would be like 130. So we'd say 130 feet. Okay. Next, it says, at what height will a rocket explode? And again, we said that was at the maximum height. Okay, so that maximum height is, I don't know, I would guess maybe 145. And then it says, how long will it take the rocket to hit the lake? So, well, let me just write this down, what I missed. For 3, that's like our y value for vertex. And then how long will it take the rocket to hit the lake? That's going to be something like your x-intercept. Okay, so here that would be, your time would be 5 seconds. All right, so it's just like that. You just look at the picture and you try to visually look at those key features that they're asking for and then locating those. All right. And it'll probably make more sense when we actually have to plug in the equation and find those key features, because that's what we did last time. All right, give this one a try, pause, and see if you can do number 2 all by yourself, and then we'll see where we're at. Okay, so number 2 says, a rock is thrown from the top of a tall building. So we have this big building over here, and a rock is being thrown. The height of the rock over time is modeled by a parabola below, where y represents the height and x represents time. So x here is time, and this is height. All right, so at what height is the rock thrown? At what height is the rock thrown? So what is that key feature that they're asking for? That's like your initial height. So that would be like your y-intercept, or at least the height for your y-intercept. So that it starts at, looks like, maybe I'll erase that so it's not taking up all that space. It looks like it's maybe 375. So the initial height, at what height is the rock thrown? 375, we'll just go with feet again. Okay. How long after the rock is thrown is it 300 feet off the ground? Okay, so we want to look at 300 feet, that's right here. Would go over and would figure out what time that was at. That's at 2 seconds. 3 says, how high is the rock after 4 seconds? So here would go to 4 seconds, would go up. And you just do your best guess. I'm just going to go just straight over there and say it's about 75. But it's probably a little less than that. If a person is walking under the building 3 seconds after the rock is thrown, will the rock hit the person? Okay, so after 3 seconds, maybe I'll do a different color this time. It's at 800 or 200 feet high. So here I would probably say no, because people aren't 200 feet high. If the person stays where he's at, then perhaps they will get hit. But at that exact moment, he probably has, because the person's probably right here. Okay. And he would have to stay at that same spot wherever the ball or the rock is falling, would need to be at time maybe almost, over 4 seconds. So they have like a little over a second to move. So hopefully they're not staying still. Okay. And how how long will it take the rock to hit the ground? Okay, and that's going to be like our x-intercept. That time, it looks like maybe 4.5 seconds. All right, so hopefully that made sense. If you have any questions, please just let me know. Looking at the graph, I mean, a lot of it is just kind of like estimating when you think where it is, because you don't have the actual numbers. But now we're going to come and do a couple where we're given the equation and we're going to need to graph it. All right, so yeah, okay. Let me make a second video for this one. All right,